Imagine a world where power is defined not by armies or economies, but by mastery of the universe's deepest rules. This is the dawn of the quantum age, a new great game, unfolding quietly in labs and boardrooms worldwide. The race for quantum dominance is on, and the winners will shape the 21st century. Like the space race or the birth of the internet, quantum technology is a paradigm shift. But this leap is even more profound. It's a new operating system for reality itself. Quantum mechanics allows particles to exist in multiple states and be linked across vast distances, what Einstein called spooky action at a distance. The implications are staggering and every major power knows it. This isn't about a single invention but building an entire ecosystem: quantum computers, ultra-precise sensors, and unhackable communication networks. The nation that leads will control economic, military, and intelligence frontiers. The race is intense, and the frontrunners are pulling away. The question is no longer if quantum will change the world but who will control it. Will open societies lead, or will authoritarian models dominate? The answer will shape privacy, security, and the global balance of power. This is the new geopolitical frontier, a battle of ideas, investment, and intellect. The stakes could not be higher. The world is watching to see who will master this quantum-powered universe. The outcome will define the next era of global leadership. The quantum age is here. The game has begun. Why does quantum technology matter so much to nations? Because it transforms security, economics, and scientific leadership. In security, quantum computers could break today's encryption, exposing secrets and communications. The first nation to build such a machine could see its rivals' secrets laid bare. Quantum sensors could detect submarines and stealth assets, while quantum navigation could bypass GPS jamming. Militaries know falling behind is not an option. Economically, quantum computing could revolutionize drug discovery, materials science, logistics, and finance. The potential value is estimated in the hundreds of billions. Scientific leadership is also at stake. History shows that nations leading in science set the global agenda. Quantum leadership attracts talent, drives innovation, and signals a nation's vision for the future. This is about more than machines. It's about demonstrating deep, foundational innovation. In the quantum race, scientific preeminence is a strategic asset. The stakes are national sovereignty, economic growth, and global influence. That's why nations are all in. The competition is existential. The United States enters the quantum race with a legacy of innovation. Its universities, labs, and tech giants like Google, IBM, and Microsoft are global leaders. The National Quantum Initiative Act committed over $1 billion to quantum research. America's strength is its public-private partnership model, blending government funding with private sector dynamism. Federal agencies fund foundational research while companies race to commercialize breakthroughs. Google's Sycamore processor and IBM's cloud-based quantum computers are milestones. But challenges remain. Bridging the gap between research and real-world products is tough. There's also tension between open collaboration and protecting sensitive technology. Recent efforts focus on domestic supply chains and nurturing homegrown talent. Leaders like Arati Prabhakar, Dario Gil, and Hartmut Nevin are driving the charge. The strategy: innovate faster, build partnerships, and protect the quantum crown jewels. America aims to ensure the next tech revolution is born at home. China's approach is the opposite, a top-down, state-driven mission. Beijing has made quantum technology central to its goal of becoming a science superpower by 2049. Its investment, tens of billions, dwarfs other nations. President Xi Jinping personally champions the cause, aiming not just to catch up but to leapfrog the West. Scientist Pan Jianwei leads China's quantum push, achieving feats like launching the world's first quantum satellite, Meteus. China has built a vast quantum communication network linking major cities. The state can mobilize resources for long-term projects, building massive labs and focusing national effort. But centralization can stifle creativity and efficiency. Still, China's progress in quantum computing, sensing, and communications is undeniable. Its strategy: achieve self-sufficiency, secure communications, and challenge Western dominance. For Beijing, the quantum race is a key front in its rivalry with the US. China's ambition and investment make it a formidable contender. The European Union, though not a single state, is a scientific powerhouse. Its quantum technologies flagship is a €1 billion, decade-long effort pooling resources across member states. Europe's strength is deep research talent and world-class institutions in Germany, France, and the Netherlands. The EU aims to turn scientific excellence into technological leadership and economic benefit, building a sovereign quantum ecosystem. Startups and SMEs are supported to bridge lab-to-market gaps. Germany and France have committed billions to build prototype quantum computers. The UK, now outside the EU, launched its own billion-pound quantum program, leveraging top universities and a vibrant commercial sector. Canada, Australia, Japan, Singapore, and India are also investing heavily. The global race is truly multipolar, not just a US-China contest. Europe's methodical, collaborative approach is shaping the future. The quantum race is global, and every major player is determined not to be left behind. The competition is fierce and wide open. But the quantum race is fought on 4 key battlegrounds. First, talent. Quantum experts are rare, and nations compete fiercely to attract them with top salaries and research freedom. Second, supply chains. Quantum computers need specialized components, cryogenics, lasers, microwave electronics, often made by just a few companies. Nations are racing to secure and onshore these critical supplies. Third, cryptography. Quantum computers threaten to break today's encryption, so the race is on to develop post-quantum cryptography. The U.S. National Institute of Standards and Technology is leading efforts to set new global standards. It's a classic offense-defense struggle in the digital realm. Fourth, intellectual property and standards. The patents and protocols set today will determine who profits and who leads tomorrow. Countries are pushing their researchers to patent aggressively and shape industry standards. Defining the rules of the quantum ecosystem is a strategic advantage. The fight is to make one's own technology the global norm. These battlegrounds will decide who controls the quantum future. The competition is relentless. Every move counts. The stakes are nothing less than technological supremacy. The quantum race is a tightrope between competition and collaboration. National security concerns drive countries to restrict technology and talent, fueling quantum nationalism. Export controls and research walls are rising, risking a world split into rival quantum blocks. Yet quantum science is so complex that breakthroughs often require global collaboration. Many top US quantum scientists were born abroad. Restricting talent could backfire. The fastest progress may come from open cooperation, not isolation. Policymakers face a tough question: how to protect security without strangling innovation. There's also an ethical imperative. Quantum tech raises issues of privacy, surveillance, and misuse. The world must work together to set norms and guardrails for responsible development. Balancing openness and security will be one of the decade's greatest challenges. We stand at a turning point. The quantum revolution is real and accelerating. The US and China lead, but Europe, the UK, and others are major players. The future may be multipolar, with different nations excelling in different quantum domains. Scientific and engineering hurdles remain immense, and geopolitical tensions could slow progress. The ethical questions are profound. Will quantum tech empower liberty, or enable surveillance and control? How we balance competition and cooperation will shape the world for generations. The race is about more than machines. It's a contest of systems and values. The outcome will define the soul of the 21st century. The world is being reshaped in today's labs and policy rooms. We must pay close attention.